A marker can be used to draw onto a polymer without scratching the surface. Paper templates can be glued onto the surface of the polymer to protect it as well as provide an outline for cutting. Steel rules and engineer squares can be used to measure and mark out straight lines accurately. The accuracy and precision of making a prototype can be improved with specific tools and equipment. A scriber will act as a pencil on the surface of a polymer, such as acrylic or high-density polystyrene. Dividers can be used to draw an accurate circle on the surface of a sheet of polymer. Calipers can be used to measure the inside and outside diameter of a tube. A digital vernier caliper can measure to an accuracy of 1/1000th of a millimeter. A junior hacksaw can be used to cut straight lines. A hacksaw is a larger version, and it can be used to cut larger sheets of polymer. Coping saws can be used to cut sheet polymer if a metal blade is fitted. Polymers can be shaped with files and abrasive paper and sanding machines. These tools and equipment remove or subtract the material. Different shaped files can be used. They are graded by their roughness or smoothness. Abrasive paper has different gradings of roughness and smoothness. Acrylic can be shaped in a school workshop with heat. A line bender or strip heater has a single conducting element that applies heat. They are a very good way to apply folds to prototypes made of acrylic. After marking out a line using a marker or scriber and a steel rule or engineer square, the sheet of acrylic is placed on the support of the strip heater. Heat is allowed to penetrate the acrylic. The plastic will become soft. This can be tested by lifting one end from the support to check flexibility. The acrylic is removed and bent to the desired angle using a bending jig. The workpiece is allowed to set, then it can be cooled down by applying water. Vacuum forming is more sophisticated than line bending. Vacuum forming can be used to make containers or electronic enclosures for prototypes. A pre-made and finished former is placed inside the chamber of the machine, and onto the platen. A sheet of high-density polystyrene is clamped in place. The heater of the vacuum former is then positioned over the sheet. This applies heat to the sheet of polystyrene. The polystyrene heats up and begins to sag. The platen is raised up towards the polystyrene sheet. The vacuum pump is switched on. This sucks out the air inside the chamber, creating a difference in air pressure. The greater pressure above forces the polystyrene to take the shape of the former. The polystyrene is allowed to cool down. The clamps are released, and the former is removed from the polystyrene. Press forming can be used to make thicker shapes than vacuum forming. An acrylic sheet is warmed up in an oven. When soft, it is removed. The sheet is placed over the plug. The yoke is placed over the plug and located by the guide pegs. Pressure is applied to the yoke. The sheet will take the shape of the mold. The sheet is left to cool, then removed and trimmed. Injection molding. Injection molding is a commercial process that is used to make many products, such as smartphone cases, chairs, and pens. Polymer granules are poured into a hopper. The granules enter the chamber. The chamber is heated. A screw powered by a motor turns and transports the granules through the heated chamber. The granules of polymer become molten. The molten polymer is injected through the shot chamber into the mold. The mold is cooled and the molded component is removed. Extrusion. Extrusion is a commercial process that is used to make continuous products made of thermoform polymers. Electric cable housing, rainwater pipes, PVC pipes, and house guttering are extruded. Polymer granules are fed into a hopper. The granules are driven through a heated chamber by a screw powered by a motor. As the screw rotates, the polymer becomes molten as it travels through the heated chamber. The molten polymer is forced through a die at the end of the extruder. The extruded polymer is pulled slowly through a cooling chamber by rollers. The extruded polymer is cut into sections or rolled into coils. Blow molding is used to make cylindrical or cavernous containers. A paricin, the name given to the polymer in a heated state, is dropped into a mold which has two parts. The paricin descends until a grip secures it in place between the two parts of the mold. Compressed air is blown into the paricin. This inflates the paricin, causing it to expand and take the shape of the mold. The paricin is cooled. The mold is opened and the bottle is trimmed.